My name is Nikolaos Mellios, and I belong to the wider community of NEXUSNet, and more specifically I'm working group 1 co-leader, which has as the core thematic dealing with monitoring and modeling the Nexus. My scientific background is on environmental engineering, and I have done my master's and my PhD degree in the University of Thessaly in Greece. I have found this opportunity for the STSM a great opportunity to broaden my horizons, so I grabbed this opportunity, and now I'm here in Bari, as you can see, this beautiful port in Bari, where I was hosted by the Technical University of Bari in conjunction with the CNR Research Center. And I had the opportunity to collaborate with Professor Vito Iacobellis and Dr. Alessandro Pagano, and of course with a PhD student, Marwa Yassin from Iraq. So the basic component that I was dealing all these days is to model the watershed of Tarquinia, which is a watershed placed nearby Rome, and where a river originates and then it flows to the sea in the eastern part of Italy. So what we did there was to cooperate with all these scientists towards modeling the basic components of the Nexus, which is water, energy, food, climate, and of course ecosystems. So our communication and our collaboration, let's say, was the fertile ground to produce a system dynamics model, the basis of the system dynamics model regarding the Nexus modeling. So we had a great collaboration in the hydrological regime of this watershed, where we used the SWOT analysis tool, and in conjunction with that we also worked together on the food sector and the energy sector. And I used my expertise to help those people to model these components, searching for data in the national statistical authorities of Italy. So now I am very happy that we have shaped the basis of this modeling procedure, where we're going to implement different future scenarios. Climatic, of course. The climatic scenarios, the worst one is the RCP 8.5, and of course we will implement some different scenarios regarding nature-based solutions that can be applied in the wider area to see how they will, let's say, impact the wider system of the river. We know that in this river we have a lot of different activities such as agriculture and livestock. So by modeling all the different components of the system, we will be in a position to foresee what will happen in future, in the years to come, in 2050, let's say, regarding the regime of these 5 components of the system. I'm very happy that we collaborated with all these people, so we exchanged ideas, as far as I'm concerned, I have broadened my horizons because this scientific team is top and is using current technologies and methodologies to model the Nexus. And of course we exchanged ideas on how to incorporate all these different components of the system. My future goal is to produce a joint scientific paper under the affiliation of NEXUSNet, which will give to the people a wider, let's say, perspective of how to model a watershed with all these anthropogenic activities. And of course, the outcome of this collaborative work will, let's say, will help to understand the various interlinkages between the components and how the system will, at the end, in the future, react in this climate change that is aforehead, and we should all take into consideration that the anthropogenic pressures should should be alleviated in order to have a future that we want. Thank you.